Ablink 3D now supports a range of different evaluation methods for measuring cylinders. So we have now the standard min, mid and max that were previously only available with circles. But we also have 2-point min, 2-point max, and also element min and element max. The idea is when you dimension the cylinder as normal, if you right click on the dimension window, there's now an evaluation method box down in the left hand corner of the dimension window itself. Click the drop down box and this gives you a range of new evaluation methods. You can also click on the information icon and this will give you a brief explanation of the different methods and how they work. And what you'll notice with this, so mid, min and max work with any cylinders. But typically the 2-point method or the elements method requires programming from template. So in these examples we need to change to 6,4 to get an evaluation. This one I actually changed to 3,5 and that did allow an element min and an element max, but you'll notice the 2-point min and max are grayed out because they don't have the correct fits. This shows in the evaluation box, you'll see we've got a little warning symbol and it says no pairs of points found. So if I remake that to 6,4 and make, let's just run that back, you'll see the software can then evaluate the correct pairs to do the 2-point method. You'll also notice the different symbols to indicate this on the screen graphically. So we have the different symbols for 2-point, which is the 2 arrows, the V and the min max signs. We then have the 3 straight lines, which is element, it's the entire cylinder. And then the standard fits, so mid is just no min max sign, and min we have the minimum sign, max we have the maximum sign. So pretty straightforward. So once this finishes, you'll see, and you can already see it on the screen now, the 2-point min and max now have pairs that they can match up with, picking the minimum and the maximum. So that is cylinder evaluation methods. We can now measure the position of cylinders within Ablink 3D. Previously, this was only available for points and circles, so it's quite a big new feature. To do so, we dimension cylinders as we normally would, but when we right click for options, you'll see the option there now is available for position. So if we select position, you'll see that drops down. Now as standard, that is going to be based from the reference system. I have done 3 different datum frames in this example, so we'll run through a few different scenarios. So firstly with this, if I right click on it, again in the datums box in the bottom right hand corner, if I click on the little magnifying glass icon, you can see this is stating it's using the reference system, so it's aligned through the references we've used in the program. However, we can add a datum frame. If we start to add a datum letter, it won't allow you to do an assessment until the full datum frame is constrained. So you'll see until I get A, B and C, which is a fully constrained datum system, it won't give me an evaluation. The other important thing to note here is when we do positions of circles and points, you would typically see the X, Y and Z nominals versus the actuals. This is what's doing the assessment. When doing this through cylinders, the nominal is taken from the template of the cylinder. So what do I mean by this? Well, if we right click on this cylinder and go to CNC, the evaluation for the position is also being based from the template of the feature. So whilst programming from CAD, this will typically be nominal. When programming on the machine, you need to make sure that the template is set correctly. So just for example, say this was actually supposed to be 2.05 in X. When I hit make, you'll see that calculation for the position of the cylinder changes. So it's really important that you get your template set correctly because that's how it's doing the analysis. So now that that's been sorted, just to show you how this works with other datum frames. If I dimension this now, right click, position, and this one I'm going to use the datum D, E and F frame. So right click, we'll set it as D, E and F. And you'll see there it's now running a different analysis. It gives us a different value. And again, if we need to see this alignment, we can click on the magnifying glass and it visually shows us the origin to the feature and how it's aligned. Now these are relatively simple setups because they're just straight down, but we can utilize a different example. So on this one, I've got the 45-degree cylinder and I'm going to apply it through the ABC system, but also through G, H and I, which are a completely different coordinate system. So dimension the cylinder as normal. Again, right click, choose position. So that will give us our position call out. Again, this is using the reference system, but we can apply A, B and C. Again, it doesn't change because A, B and C are the actual reference system. However, we can also do it to a different datum frame. Again, position, and this one I'll use G, H and I. And you'll see we get a different value because it's using a different evaluation through this datum frame instead of the reference system. And again, just to showcase this, if I click the icon, you can see now the alignment is through the G plane, the origin is the H point, and the rotation is through the I plane. It's also worth noting you do get a visual of the cylinder assessment. So we have the target zone and the line running through it. A little bit trickier to see here. So this is a visual ID of the line of this axis cylinder versus the nominal. And you'll see because it's outside of that window, it's showing up red visually. This was the same for this cylinder. You can zoom in and see the target zone versus the actual. This is displayed as soon as you right click the dimension. So yeah, this is a big step forward. So we can now do the position of cylinders, but the critical things to note are that the values are based from the template of the feature.